Alright, problem 1. Cost varies directly as number purchased. 8 can be purchased for $56. How much would 15 cost? When we see a direct variation, and I'm going to use the equal ratio method, cost varies directly as number purchased. So if it's a direct variation, the subscripted variables are directly across from each other. 8 is how many are being purchased, $56 is the cost, so the initial cost, the initial number purchased. How much would 15 cost? So we don't know how much it costs, but we're trying to buy 15 of them. So it creates a nice little proportion for us. If I cross multiply, this product, which is going to be 8 times C2, is going to equal that product, 56 times 15, 840. We simply divide both sides by 8, and we get $105. Number 2, blues vary inversely as yellows squared. So blues vary, so that's B sub 1 over B sub 2. It says inversely, so that means the yellow sub 1 and yellow sub 2 are going to be inverted. But it says yellows squared, so it's going to be squared, squared. So subscripts below, powers above. And once again, they tell us stuff that we can figure things out. The initial number of blues, 80, goes with the initial number of yellows, 4. But it is squared, so when I put 4 in, 4 squared, 16. How many blues? We don't know. B sub 2. Go with 16 yellows, so 16 squared is 256. These are big enough numbers I probably want to reduce, so that cancels 16 and 1. Now if I cross multiply, I get 16 times B sub 2 is equal to 80. Divide by 16, we get B sub 2 is equal to 5 blues. So direct variation for the first one, inverse variation for the other one. Again, that's the equal ratio method. If you want to look up the K technique on those, watch a different video from a previous lesson. Number 3, dogs were $35 each, cats cost only $4 each. Doe Run bought 42 animals and paid a total of $1,036, so it's just a basic two unknowns situation. We got enough information to make 2 equations. Number of animals purchased is 42, so that means the number of dogs plus the number of cats is equal to the number of animals. And paid $1,036. So now the value of the animals is important. So every dog is $35. That means 35 times D represents how much money is spent on dogs. Every cat's $4. So $4 times the number of cats is equal to the total amount of money paid for everything. And at this point, I'd probably take the top equation by -4 to get rid of the C's. So -4 goes there. I get -4D minus 4C is equal to -168. 31D is equal to $868. So if we divide both sides by 31, let's see, it's like 20, 62, 248, 28. So 28 dogs. And since he purchased 42 animals, that means 14 cats. Number 4, so we have a radical equation. Anytime you have a radical equation, you want the radical isolated, so I would want to get this all by itself on the left, everything else on the right. So square root of x squared minus 3x plus 5 is going to equal -x plus 7, or 7 minus x, take your pick how you want to write that. Once you get the radical isolated, we square both sides. And the end result of that is on this side just x squared minus 3x plus 5. The radical disappears. On this side we square the binomial. First thing squared, double the product of the two things. Second thing squared. The squares are always positive. The double product is always the sign of the product. In this case, -7x double -14x. I would probably move, or just strike the x squareds out, so there's one on both sides. Move that over, change the sign, they cancel. I would move the 5 over here, and the 14x over there. It gives me 11x on this side equals 44 on this side. So x equals 4 is the candidate for the right answer. Once we do one of these problems, we always want to verify that the solution actually works. And the way we do that is we go back to the original problem, replace all the x's with the answer we just found. We found 4, so we get the square root of 16 minus 12 plus 5 plus 4 minus 7 is supposed to equal 0. 16 minus 12 is 4 plus 5 is 9. And that's 3 plus 4 is 7 minus 7 equals 0 is true, so that's a good answer. You only have to do this to the extent you know it's right. Once you know it's right, just move on. If this happens to be wrong, throw that out and put the empty set. Number 5, same type of problem, only difference here we have too many radicals. We have 2 radicals specifically. I'm going to isolate this one first because it's got more stuff going on in it. I'm going to move that over to the other side. Square root of p minus 11 is equal to 11 minus the square root of p. 1 object, 2 objects, so when we square both sides, this is just going to be p minus 11, the radical disappears, where this has to be that squaring the binomial deal again. So 11 squared is 121. Double the product is negative 22 times the square root of p, and square root of p squared is going to be p. Again, the perfect squares are positive. The double product is going to be the sign of the product. I've got p's on both sides. They cancel. I can move the 22 square root of p over there, the 11 over here. I like my square root object to be positive, so positive 22 times the square root of p. Move the 11 over, plus 11 makes 132. Divide both sides by 22. So the square root of p is equal to 6, which means therefore, once again, just like this had square root equals something else, now we have square root equals something else. Square this, square this. Square root of p squared is p, 6 squared is 36. That represents the only number in the world that could possibly be the right answer to this problem. We just have to verify that it actually works. Go back to the original problem. Each p gets changed to a 36. 36 minus 11 is 25. Square root of 25 is 5. Square root of 36 is 6. 5 and 6 makes 11 is a true statement, so that would be the right answer. Number 6. System of 3 equations with 3 variables. The bottom equation here looks the easiest to get to say one thing equals everything else. So if I move the z over, I get 2x is equal to z. That information is now allowing me to go up to this and to this and change those z's into 2x's. So the top equation top equation in red. So I'm going to get x plus y plus, instead of z, I'm going to put 2x is equal to 17. And that becomes 3x plus y is equal to 17. Going to the middle equation, I get 2x minus 3y. Instead of minus z, I put minus 2x is equal to negative 15. And if I combine like terms there, the x's actually cancel. They're going to be negative 3y is equal to negative 15. So we went from the system of 3 equations with 3 variables through substitution of the bottom equation into the top 2. I get a system of equations with 2 variables. And an extra added feature here, which doesn't always happen, but it happens here. Usually, but from this point, we'd have to do elimination or substitution. Well, this bottom equation is just going to be y equals 5. Divide both sides by negative 3. And if y equals 5, that means the top equation becomes 3x plus 5 is equal to 17. Which means 3x equals 12, which means x equals 4. And once I know x equals 4, I know z is equal to 2 times x, so z is equal to 8. And then once I have all 3 answers, x followed by y followed by z is the solution. Okay. If this didn't happen on the test, let's say this said 2x minus 3y equals negative 15. Now just to use basic elimination technique, find x and y. And once you know x and y, again, go back here to find z. But again, when only a single variable is left in one of these equations, you're just ready to solve it immediately. Number 7, we're adding, and if I've got a quadratic trinomial denominator, the first step of adding is to factor, if at all possible. Negative 3x minus 12 is fine as it is on top. On the bottom, x plus 3 times x minus 1. And what you're supposed to notice is this is 1 minus x, and this is x minus 1. They're almost the same, except for the signs are messed up. So the second fraction, I'm going to change this to an x minus 1. In order to change the signs in the bottom, I've got to change the signs one other spot. I'm going to change the front to a plus. As I've said many times, if that's a plus, keep it plus. If it's a minus, change it to a plus. That's one sign change. The bottom sign's changing as the second sign change. And then 4 stays 4. So that red fraction is equivalent to the black fraction above it right here. Just change that sign, change those signs, the equivalent fraction. Once I get to this point, I notice that this has an x plus 3 on it, which this doesn't, so I need to put an x plus 3 on this, and x plus 3 on the top to account for that change. And my end result is a common denominator for both fractions of x plus 3 times x minus 1. And then, of course, I got a negative 3x minus 12 for the first fraction. I've got a plus 4x and a plus 12 for the second fraction. The minus 12 and plus 12 cancel. And then if I combine like terms, I end up with positive 1x over x plus 3 times x minus 1. No guarantees that this type of thing where they're exact opposites will happen, but there'll be some like terms, so go ahead and combine the like terms to get the correct signs on your answers. And leave the bottom in factored form, that's perfectly fine. Number 8, we have a binomial radical denominator. We're supposed to simplify. The square root of the denominator is the problem. Multiplication by its conjugate, 2 minus the square root of 3, is going to fix it. The top times the same thing. The top I have to use FOIL to multiply it out. Just bring that down a smidge. So if I do first times first, I'm going to get 4 times the square root of 3. If I do outside times outside, I'm going to get minus 2 times 3. If I do inside times inside, I get minus 3 times 2. And if I do last times last, I'm going to get a plus 3 times the square root of 3. Put this upside down. That looks better. Alright, so just like that we did FOIL, and again, a positive product, a negative product, a negative product, and a positive product, and I multiply the whole number times whole number, radical times radical. When the radicals are the same type, you get a nice whole number out. On the bottom, instead of doing FOIL, I just have to do the first and the last. So first times first makes positive 4. Last times last makes minus 3. Once again, square root of 3 times the square root of 3 just makes 3. The opposite signs create a negative. The outside and inside products there will cancel, so we don't have to worry about that. So the end result on the bottom is just 1. On top, negative 6 minus 6 is negative 12. Positive 4 square root of 3 plus 3 square root of 3 is going to be plus 7 times the square root of 3. That's a perfectly fine answer, or you can just go with negative 12 plus 7 times the square root of 3, since over 1 doesn't really matter. Number 9, find B. Okay, first thing I want to do is find A. I know that a squared is equal to b, leg squared plus leg squared, so 9 plus 16. That means a squared is 25, so a is going to equal the square root of 25, which is 5. So right triangle's right there, Pythagorean theorem finds it for us. Our job is to find the length of B, and what I would do is use the fact that this side corresponds to this side because they're both opposite this equal angle. And of course, 5 is opposite the right angle. 5 plus b is also opposite the right angle. I don't have any information about this piece here, so this angle up here that's equal to this angle over here has no help. It offers us no help in doing this problem. So I set up my proportions here. If I put 3 and 5 on top, they both come from the smaller triangle. and 3 goes with 9, and 5 goes with 5 plus b. Just like that, we have a nice little proportion set up. And if we cross multiply this product, which is going to be 15 plus 3b, is equal to this product, which is 45. Then if I go ahead and solve it, move the 15 over here, I'm going to get 3b is equal to 30. So therefore b is equal to 10. Again, that's what they asked us to find. That's what I did find. You can't find b without finding a, though. So again, even though it doesn't ask you to find a, that'd be the first thing you want to do. Number 10, similar triangles to find exact values of m and n. And what we want to do first is we want to draw a triangle, right triangle, the same orientation as that one. So there we go. 45, 45, 9. It doesn't matter how big it is, but just know that we have a 45-degree angle down here. This, of course, is 45 up here also, as this would be to be a 90-degree angle down here. And every 45, 45, 90 right triangle is similar to one that has dimensions of 1 and 1 for the legs, square root of 2 for the hypotenuse. It does say exact values. That means we want radical answers. The proportion I'm going to use here is to find m and n is this. I know that m, 4, and n all come from the bigger triangle here. And I can see from the smaller triangle that m corresponds to 1, 4 corresponds to 1, and n corresponds to the square root of 2. So if I just cross multiply, this is m equals 4. That's the exact answer for m. And this one is going to be n equals 4 times the square root of 2. That's the exact answer for that one. So the only other thing that might happen on a problem like this is if you divide by a square root of 2, then of course multiply top and bottom by the square root of 2 to fix it. But again, that's pretty much how it's going to look on the test. I would expect to work similarly. Number 11, we have a fraction and a decimal equation in a system of equations. First thing I want to do is multiply by the common denominator of this, and I want to move every decimal point 2 spaces to the right for that in order to get the fractions and decimals out of the problem. So 12 divided by 3 is 4 times 2x is 8x for this one. 12 divided by 4 is 3 times negative y makes negative 3y for that one. And 3 times 12 is 36. On the bottom I'm going to get 7x plus 6y is equal to 135. Now it's just a basic system of equations, all integer values. Eliminating y would be the easiest. If I double the numerator, or I should say the top of this, that makes negative 6y to go with that positive 6y, and the consequence is that this becomes 16x, and this becomes 72, and of course, the negative 6y we wanted. So, instead of having that equation, we have this one on the bottom. If I add the equations together, 7 plus 16 is 23x, positive and negative 6y cancel, 135 plus 72 is 207. Divide both sides by 23. And we end up with x equals 9. Once we know that x equals 9, I go back to any equation. I'm going to take this one right here. I know 7x, x is 9, plus 6y is equal to 135. That's 63, so I'll move it over, it becomes negative 63, so 6y is equal to 72. Dividing both sides by 6 leaves me with y equals 12. And as always, I've got x and y in a system of equations. I want an ordered pair, x first, y second. Number 12, solve negative x squared equals negative 3x minus 7. It's a quadratic equation. I like x squared to be positive, so I'm going to move the x squared over to the right. I need it equals 0. So 0 is equal to 1x squared minus 3x minus 7. A is equal to 1, B is equal to negative 3, C is equal to negative 7. And I know my answer is going to have the form of x equals something plus or minus the square root of something over something. And the three somethings are, right here, the opposite of B. B is negative 3, opposite of B is positive 3. What goes in the bottom is 2 times A is 1, 2 times A is 2. And what goes in the radical is B squared minus 4AC. b squared is going to be positive 9, b squared is always positive, minus 4 times a times c. A is positive 1, c is negative 7. Two negatives make a positive, so it'll be positive 28. 9 plus 28 is 37. There's your answers. So the quadratic formula is very effective on that one. Square root of 37 can't be simplified any more than that, so that's the best answer possible on that. 840 cubic centimeters per minute to cubic feet per hour. So 840 centimeters cubed per minute. Okay, so we have two conversions happening here. We want to change cubic centimeters to cubic feet. I'm going to do that first. So I know that 2.54 centimeters is equal to 1 inch. This is cubic centimeters, so I have to cube this, which cubes centimeters, cubes 2.54, cubes inches, cubes 1. Now I'm in cubic inches, I want cubic feet. I know that 12 inches equals 1 foot. Once again, this is cubic inches, this is just inches, this also needs to be cubed. So now it's cubic inches cancels cubic inches. So cubic centimeters cancel. Cubic inches and cubic inches cancel. And we're left with 840 divided by 2.54 divided by 12 cubed to get the cubic centimeters to cubic feet. The other conversions going on here is we're trying to change per minute to per hour. And that requires me to use the fact that there are 60 minutes in 1 hour. Notice that this is minutes, not cubic minutes. This is also minutes, so that multiplier doesn't have to be cubed. That's perfectly fine the way it is. So both of these got cubed because we're dealing with cubic units. This is not cubic, so we just get 61 time happening there. And then it's just a matter of using our calculator. So 840 divided by 2.54 to the third divided by 12 to the third times 60. Comes out to 1.78 cubic feet per hour. Number 14, simplify the fifth root of x cubed y squared being multiplied by the cube root of x squared y to the fifth. These two guys are both being raised to the fifth power, and both of these are being raised to the third power, and they've got the third and second power inside. So basically what I got to do is, if I'm focusing on this one here, that's x on the inside, we take power divided by root. Focus on this one here. Y is the base, 2 fifth power is what we... Alright, so x to the 3 fifths, y to the 2 fifths. Power divided by root for each one. The second one, we have x right here, and we take the 2/3 power, and we got y right here, and that's going to be the 5/3 power. So that's priority one. Get them all out of the radical structure into the fractional power. And then, each common letter, we're going to get a common denominator. So, for these two, the common denominator is 15 times 3 times 3 times 5 times 5. For y, common denominator 15 times 3 times 3 times 5 times 5. And we end up with a final answer of x to the 19 fifteenths, y to the 31 fifteenths. Okay, on the test you should expect the exact same structure. Of course the numbers will change. Get them all to fractional power structure, get your common denominator, add them together correctly. And finally, 15. Find the equation line that passes to the point negative 5, 3 is perpendicular to the line 5x minus 2y minus 1 equals 0. If something's perpendicular to a given line, that means the slopes are opposite reciprocals one another. So that's my first part. Always when it says find the equation line, how do I find slope is the question I need to ask myself. In this case, if I get this to say y equals, so I'm going to get negative 2y is equal to negative 5x plus 1. So y is equal to positive 5 halves x minus a half. So I get that to say y equals. The slope of the line they're giving me is 5 halves, which means the slope of the line I'm looking for, the perpendicular slope, is going to be negative 2 fifths. So again, that's priority one. Find the slope that we need. So once I've done all this stuff and I've gotten that slope, now the point I care about is negative 5, 3. That's the point of the line I'm looking for. And I know the slope of the line I'm looking for is negative 2/5. And I know y is equal to m times x plus b. Negative negative makes a positive, the 5's cancel, so I'm going to get positive 2 plus b, so b is equal to 1. Slope of negative 2/5, y-intercept of 1, y equals negative 2/5 x plus 1.